Assalamualaikum and hi everyone. In this video, we are going to learn about quantization of light. So in this chapter, we have two subtopics. The first one is Planck quantum theory, and the equation involved is E equal to hf equal to hc of lambda. And for 9.2, it's about photoelectric effect. We are going to look at Einstein photoelectric effect, and the equation involved is E equal to maximum kinetic energy plus work function, or we call as W naught. So in Planck quantum theory, we need to know about black body radiation and the classical theory of energy. So what is black body? A black body is an ideal system that absorbs and emits all the electromagnetic radiation that incident on it. So the EM radiation emitted by black body is called black body radiation. So what we need to know is every object radiates energy. So this energy is emitted at different wavelength of light. So the distribution of this energy is called black body curve. So as we can see, the curve change with an object's temperature. Next, we look at the classical theory of energy. The distribution of energy in black body energy depends only on the temperature. So we get the formula E equal to kT, where the K is the Boltzmann constant and T is the absolute temperature. And the second one, energy of the EM radiation is emitted continuously and can take any value. As we can see from the graph, the classical theory cannot explain the observed distribution of EM radiation. So this leads to the rise of quantum physics. The classical physics predict that as the wavelength approaches zero, the amount of energy radiated should become infinite. But experimentally, it was shown that as the wavelength approaches zero, the amount of energy radiated also approaching zero. So from this, Max Planck proposed his theory that fit with the experimental curve at all wavelengths, known as Planck's quantum theory. So Planck's quantum theory has two statements. The first one is the EM radiation from black body was emitted in discrete or separate packets of energy. Each packet is called quantum of energy. This means that the energy of EM radiation is quantized. So not all values of energy are possible. The second one is the quantum of energy E for the radiation of frequency f is given by E equal to hf, where h is the Planck constant, the value is 6.63 exponent negative 34 joules per second, and f is the frequency of the radiation. So as we can see, as the frequency of the light increases, so the energy also increases. 5 years later, Einstein suggests that light is quantized or made of tiny bundles of energy called photons. So each photon of frequency has a discrete energy given by E equal to hf. Since the speed of the light in vacuum is c equal to f lambda, thus we get E equal to hc over lambda. So this is the Einstein formula for photon energy, where E is the photon energy, h is the Planck constant, f frequency of radiation, c speed of light, and lambda is the wavelength. Since the energy of the photon is very small, so we can express it in electron volts. So 1 electron volts equal to 1.6 exponent negative 19 joule.